Hello guys, we are back with balancing of chemical equation part 2. In this we are going to balance some chemical equation that's quite difficult for you. While balancing sometimes you have to use some fractional number. How to make it easy? Let's go with that. Okay, let's get started with this chemical equation that we are having here. So just to balance it, we have to check again metal, non-metal, hydrogen and oxygen. Now in this case, you may see we don't have any metal. So we are going to skip this step, but we are having non-metal, that's carbon, and we are having hydrogen and oxygen as well in this. Now let's count it. If we are counting the carbon, we can see we are having 2 carbon on left hand side while 1 on right hand side. Just to make it same, what we are going to do, we are going to make it times 2 so that we can get same number of carbon on both sides. So very first I am going to put the bracket over it and then I will write 2. Now you can see you are having 2 times of 1, 2 on both sides. Now carbons are got balanced. Let's come to the hydrogen. When we are counting the hydrogen, we are having here 6. Okay. And then let's check on the other side. We are having only 2. Now to make it same, I am going to multiply it with 3 so that I can get the same number on both sides. So while doing it, again I have to put the bracket and I will write 3 in front of it. So that will give me 6 hydrogen. So I got carbon and hydrogen same on both sides. Now it's a time of to balance oxygen. While we are balancing oxygen, we can see we are having only 2 oxygen on left hand side. While on other side, you can see you are having oxygen with carbon dioxide and oxygen with water as well. So let's count oxygen individually. So we are having in total 4 oxygen in case of carbon dioxide, while we are having 3 oxygen in case of water. So in total, what we are having in total 7 oxygen. Okay, so one side we are having 2, other side we are having 7. So I can't do crisscross here because if I am going to do the crisscross, I am okay with the oxygen molecule. But in the case of this, I can't do it. Why? Because if I am doing something crisscross here, my hydrogen is not going to be balanced easily. So for that, what I can do, okay, if I will do the multiplication of this 2 by a fractional number 7 by 2, then what I am going to get? I am going to get 7 of 7. It means 7 oxygen on both sides. Now, what is this? Let's check it out. For diatomic molecules, what we can do this type of multiplication. Diatomic molecule mean like oxygen, fluorine, nitrogen, chlorine, bromine, iodine, etc. Any of the molecule, any of the element that comes to the molecular form. So in that only we can do this type of multiplication. Now let's do it. Now it doesn't look nice. So just to make it more precise, what I'm going to do, after this I'm going to make it times 2 throughout. So as I'm going to do it, what I'm going to have, I'm going to have 2C2H6 plus 2 times of 7 by 2 O2. Then I'm going to have 4 carbon dioxide. And then we are having previously water here. Now what I am going to have, I am going to have 6 water molecule after the multiplication of 2 throughout. Now you can see this 2 get cancelled out with this, so I am left behind with 2 of C2H6 and 7 of O2, which gives me 4 CO2 and 6 H2O. Now let's count it once again. Carbon, hydrogen, oxygen. Now if you will count them with respect to their number of atoms, you may see you are having 4 carbons on left, 4 carbons on right. That's fine. Now similarly you can see on the next what you are having, that's hydrogen, and when you are checking it for hydrogen, you are having in total 12 hydrogen here and 12 hydrogen here. That's also fine. Now it's time to check it for oxygen. So we are having 14 oxygen, and here if we will count it, it's 8 oxygen from carbon dioxide and 6 oxygen from water. And if I am going to add them up, what I am going to get, I will get 14 oxygen once again. So that's my balanced equation. So hope you get it. Now to make it more precise, let's jump into the next example. Okay, so in the next example, we are having iron sulfide. Okay, let's write down all the 4 steps that we know how we are going to balance. Firstly, we will check metal, non-metal, and then hydrogen and oxygen. So as you can see, you are having metal, that's iron, non-metal sulfur, and we don't have any hydrogen, so we are going to skip this step. We are having oxygen. Okay, let's count it. If I can see, I am having only 1 iron on left, while I am having 2 iron on right. To make it same, what I am going to do, I will make it times 2 on left hand side. Now you know, as it's a molecule, you can say it's a compound. So what we can do, I can write down 2 here. So by doing it, I will get same number of iron on both sides. Now let's check it for sulfur. While we are checking it for sulfur, I can make it times 2 times 2. It's going to be 4 on left hand side, while only 1 on right hand side. To make it same, what I am going to do, I am going to make it times 4 on right hand side. Let's do it. So as we are doing it, we can see we are having 4 on both sides. So we got same number of sulfur atom. Now it's time to check it for oxygen. Now let's check it for oxygen. So as we are checking it for oxygen, I can see 2 oxygen are there on left hand side. Okay, again I am having oxygen with iron oxide and with sulfur oxide. Now let's check it. We are having 3 oxygen in case of iron oxide, and we are having 8 oxygen in case of sulfur dioxide. So now when we are adding them up, we are getting in total 11 oxygen. Okay, now again I can't do crisscross because one side I am having diatomic molecule, other side I am having a triatomic molecule, because in this 3 atoms are there. So what I am going to do, again I am going to multiply it with the fractional number so that I can get same number of atoms on both sides. So let's do it. Okay, you know, this reaction, to make it more simple, because we can't use the fractional number of molecule, so what I'm going to do, despite of that, I'm going to multiply this whole equation by 2. Let me rewrite the equation. So we are having this 2 of iron sulfide, 11 by 2 of oxygen, which gives you iron oxide, and 4 of sulfur dioxide. Now what I am going to do, I am going to multiply this whole equation by 2. And when I am making it 2, what I am going to get, let's see. So I am going to get 4 of iron sulfide, 2 times of 11 by 2 of oxygen, and then here I am going to have 2 of iron oxide, and then what I am going to have here, I am going to have 4 of, okay, sorry, it's going to be 8 of sulfur dioxide. Now, as we can see, this 2 will cancel out. What I am left behind? I am left behind with 4 of FeS2 and 11 of O2. Then it gives you 2 of Fe2O3 plus 8 of SO2. Now let's check it once again. Metal, non-metal, and oxygen. In this case, we don't have any hydrogen, so we are skipping that step. Now let's check it together. Okay, what about iron? We are having 4 on left and 4 on right. That's fine. Now let's check it for sulfur. We are having 8 on left and 8 on right. Now let's check it for oxygen. For oxygen, we are having 22 oxygen on left. Now let's check it for this. You can see oxygen is present with respect to both the molecules or one side of compound, with iron compound and with sulfur molecule. Let's check it. Now in this case, it's going to be 2 times of 3, 6 oxygen here, and 8 times of 2 will give you 16 oxygen. So if I'm going to add them up, what I'm going to get is collectively, on the addition of this, I am going to get 22 oxygen. Yes, so I got this as balanced equation. Hope it makes sense. Now for more practice, let's go to the next example. Okay, so now in this example, we are having ammonia, okay, that is reacted with oxygen to give you nitric oxide and water. Okay, now you can see you don't have any metal in this case, so let's skip this step. But we are having non-metal with us, that's nitrogen, and we are having hydrogen and oxygen in this case. Now let's count nitrogen. It is 1 on left while 1 on right. Okay, that's fine. Now let's check it for hydrogen. We are having 3 on left, okay, while 2 on right. Okay, so what we have to do in this case, now if we are having 3 on left and 2 on right, now what we can do, we can do crisscross. Okay, let's go in that way. So if I'm going to make it times 2 on left and make it times 3 on right, what can I say? Let me write down. Here I have to write 2. Okay, and what I'm going to do here, I'm going to write with water, it's going to be times 3. Now you can see you are having 6 hydrogen on left hand side and 6 hydrogen on right hand side. Yes, but wait, while doing this, my nitrogen also get disturbed. Now I am having 2 nitrogen on left while only 1 on right. To make it same, what I can do, I will make it times 2 on right hand side. Okay, let me change the color. Now let me write down 2. Okay, now in this case, what we can see here, now we are having same number of nitrogen, that's 2 or 2. Now last but not least, we are having oxygen. Let's count it for oxygen. We are having only 2 oxygen on left hand side. Okay, we can see we are having oxygen with both the molecules. Now here we are having 2 oxygen while here we are having 3 oxygen. If I will add them up, I am going to get 5 oxygen. Okay, now again one side I am having diatomic molecule, but here I am having triatomic molecule. So I can't do the crisscross method here. I can't do the cross multiplication. So what I can do, I can multiply the diatomic molecule with fractional number, which is going to result the same number of oxygen. Now let's do it. So I will write down 5 by 2. Okay, now you know what we are left behind. We are left behind with 2 of ammonia, 5 by 2 of oxygen, which gives you 2 of nitric oxide and 3 of water molecule. Now what we are going to do? We are going to multiply this whole equation by 2 because we don't want this fractional number with us. So let's do it. So as we are multiplying the whole equation by 2, so it's going to be 4 of ammonia. Then 2 is coming inside, it's going to be 2 times of 5 by 2 of O2. And you will get 4 of nitric oxide. And with water, we will see 6. Now you can see this 2 is going to get cancelled out. And we are left behind with 4 of ammonia, 5 of oxygen molecule, 4 of nitric oxide, and 6 of water molecule. Now let's count the atoms. again we are having nitrogen, hydrogen and oxygen. Let's check it. We are having 4 nitrogen on left hand side and the same on right hand side as well. Now let's check it for hydrogen. We are having in total 4 times of 3, that's going to be 12 hydrogen on left hand side, and 6 times of 2, again 12 hydrogen on right hand side. We are good in that. Okay, now let's check it for oxygen. We are left behind with now with 10 oxygen on left hand side. Okay, as we can see we are having oxygen on both sides. Okay, so here we are having 4 oxygen and here we are having 6 times of 1, 6 oxygen. On addition, again we are getting 10 oxygen. Okay, so by doing it, we got our balanced equation. Yes, now let's go to next. Okay, so again we are having a pretty easy equation for us. Now let's try it together. So we are having, again if I can see, I don't have any metal in this. So let's go to the non-metal, hydrogen and oxygen. Okay, and the non-metal I am having carbon and rest I am having hydrogen and oxygen. Let's count the carbon. If you can see, I am having 4 carbons on the left hand side, only one is there on right hand side. Now just to make it same, I am going to make it times 4 so that I can get the same number of atom on both sides. For doing that, what I can do, I will put the bracket first and write down 4 here. Yes, so now I can get easily 4 times of 1, 4. Okay, now let's go to hydrogen. If you can see, I am having in total 10 hydrogen on this side, while here I am having only 2. To just make it same, I am going to multiply this hydrogen with 5. Okay, so as I am doing it, I can see I am going to get the same number of hydrogen on this side as well. Okay, now let's go to the oxygen. For oxygen, I can see I am having 2 oxygen on left hand side. While if you can see, you are having oxygen with both of the molecule. Now let's check it. Here I am having 4 times of 2, that's going to be 8 oxygen. While here I am having 5 times of 1, which is going to be 5 oxygen. So in total, I am going to have 8 oxygen plus 5 oxygen, which is giving me 13 oxygen. Okay, again here you are having diatomic molecule, so you can easily write down the fractional number. Yes, but here I am having triatomic molecule, I can't change anything, so I am going to simply solve it down. What I am going to get, I am going to left behind with 13 out of 13 after writing 13 by 2. Now let me rewrite the equation so that we can multiply the whole equation by 2 to remove this fractional number. Okay, now let's do it quickly. So we are having this. Now let's multiply the whole equation by 2. Let's make it times 2. Okay, as we are making it times 2, what we are going to have? We are going to have 2C4H10 plus 2 times of 13 by 2 O2, which gives you 8 carbon dioxide and which gives you 10 water molecules. Now you can see this 2 will get cancelled out and we are left behind with 2C4H10 and 13 O2, which gives you 8 CO2 and 10 H2O. Now let's go to next. Okay, so here when we are checking it, so what do we have in this case? Let's write down the elements. Here we are having carbon 8, 8, that's fine. Hydrogen, that's going to be 20 on this side and 20 on this side, that's fine. And then let's go to oxygen. So in the case of oxygen, if you can see, it is 13 times 2, which is going to be 26. And here we are having oxygen with both the molecules. Let's check it together. It's going to be 8 times 2, 16 oxygen, and here 10 times 1, which is going to be 10 oxygens. So in addition of these two numbers, what do we check? We will get 26 oxygen. So we got our balanced equation. Hope you got this method, and if you have any question, please don't forget to comment on that and send me an email. Thank you so much.